Hey everybody, for today's lesson we're going to start with a warm-up activity that will take, I don't know, 5 minutes or so. And what I want you to do is I want you to take out maybe a couple pieces of loose leaf, and I want you to complete the square, solve for the x-intercepts on these two equations by completing the square. You could try factoring if you wanted to, but trust me, these guys don't factor. There are not, this one's easy to tell. 2 times -7 is -14. There are not two factors of -14 that would have a difference of 3. So that for sure doesn't factor, and trust me on this one, that's not going to factor either. So take out, again, 2 pieces of loose leaf. Do each one on its own page. You'll kind of see why I want to do that in a bit. Those of you take a second and take 2 pieces of loose leaf and solve this one by complete the square, solve that one. Pause the video and actually do that task, and then start the video back up once you've gotten your exact answers. Remember, exact means leave the final answer in radical form if it doesn't factor. Okay, so pause the video and give that a try. Okay, let's go through the A one first. So if I'm going to complete the square, I'm doing it so that I can find the x-intercepts. What do I know about the x-intercepts? Well, they happen when y is 0. So that's the first thing, to set y to be 0 so that I can solve for the x-intercepts. Step 2, if I'm completing the square, I have to factor out this 2 from the first 2 terms. So that's going to be that minus that. Okay, next step is I'd like to actually complete the square. I ask myself, what would I like this number in here to be that would make this a perfect square trinomial? And the answer to that is, of course, it's half of 3 halves squared. If you need scrap paper to figure out what that is, use some scrap paper, but I can just figure it out. Half of 3 halves is 3/4, and 3/4 squared is 9/16. Now, I can't change the equation by adding something without taking it away again right away to balance that. So, but remember, I didn't really add 9/16. I added 2 times 9/16, which is actually 9/8. So I'm going to take away 9/8. In the next step, I'm going to kind of do 2 things at once here. I'm going to make that its perfect square. So that's x minus, I know it's a minus because that's a minus, and then the square root of this term is always what goes here, so that's 3/4. And then 8 is my common denominator of 1 and 8, so 7 over 1 is equal to 56 over 8, so 56 and 9 is 65. Then I'm going to, in the next step, add 65/8 to both sides, right? I'm into now the part where I have to isolate for x. After all, I'm solving for x here, right? I'm going to divide both sides of the equation by 2. And now I've hit the part where I have to eliminate this squared by square rooting both sides. I have no idea what the square root of 65 is, so I'll leave it as plus or minus 65, or plus or minus the root of 65. But I do know the square root of 16 is 4, which is actually kind of nice because that means it has a common denominator with the term on the other side. So when I add 3/4 to both sides to finally say I've solved for x, I can just create that as one fraction. It is actually 3 plus or minus the square root of 65 over 4. Okay, now let's get a decimal approximation for that. I know we don't, I did ask for an exact answer, but I'm going to check to see how we did with this by using Desmos and graph. So I kind of want to know what the decimal approximation of that is. So open a bracket and go 3 plus the square root of 65. Close the bracket and divide by 4. And as you can see, it's 2.77 if I rounded it to 2 places. So x is approximately equal to 2.77. And the other answer would be 3 minus the square root of 65. Close my bracket, divided by 4. And that would be negative 1.27. So negative 1.27. And let's check out on Desmos and see how we did. So I already have this kind of preloaded. So let's see, video, where are you, window capture 2? There we go. And as you can see here, let's see, we've got, I've got this one kind of preloaded already. And we have 2x squared minus 3x minus 7, which is this graph here, and that x-intercept is 1.2. Oh, they actually have 3 decimal places, so yeah, that's the same number we got there. and that's the same number we got here. By the way, if anybody's wondering what's different about applied math versus pre-cal math, this is one of the differences. We actually don't teach the applied students how to do things like complete the square, but they're expected to solve the same quadratic problems that you guys have to, so they get to use technology. They can use Desmos or they can use a graphing calculator, and basically this is how they find their answers. Okay, cool. So that's the first step. Second step is let's do the B question. So let's have a look at the B question. All right, there's the B question. So from here, we're going to start again by setting that to 0. And this is going to be 0 equals 2/3 x squared minus 3/5 x minus a quarter. And we have a couple of ways we can approach this kind of question. I would not want to work with all these fractions. I could. I mean, you could complete the square with these fractions. You'll get the right answer. But why don't we eliminate the fractions by thinking about what the common denominator is, which is 3 times 4 times 5, because there's no common factors there, which is 60, right? 3 times 4 is 12, 12 times 5 is 60. So I'm going to multiply both sides of the equation by 60. So 0 is equal to 60 times 2/3 x squared minus 3/5 of x times 60. I'm timesing all the terms here by 60, minus a quarter times 60. All right, what kind of numbers will I get when I do that? Well, what's going to happen is 3 is going to go into 60 20 times, so I'm going to get 40x squared. 6 is going to go into, or sorry, 5 is going to go into 60 12 times, so that's minus 36x. And 4 goes into 60 15 times, so minus 15. Now, are there any common factors there? Wouldn't that be nice if there was, if I could make that smaller by dividing a common factor? But I don't think there are. 2, 4, and 8 go into 40. 2 and 4 go into 36. But there's no even numbers in 15. 15 and 36 both have a 3, but there's no 3's in 40. So sadly, I got to work with these great big numbers. All right, we got to complete the square with some big numbers. Step 1, we are going to factor out a 40. So that's going to be x squared minus 36/40 x minus 15. I can simplify that, which I'm going to do. I'm going to take a second and simplify that. That's going to be x squared minus, these two things have a 4 in it, so that's 9/10 of x minus 15. There we go. Now, what would I like this to be? Well, I'd like this to be half of 9/10 squared. Half of 9/10 is 9/20, and 9/20 squared minus 9/10 x. 9/20 squared would be 81/400. Ew. Okay, so 81/400. Now I just added 40 times 81/400 to my equation. So I have to minus that right away. So if I times 40 by 81/400, I'm still going to get an 81 on the top, but do this on scrap paper if you need to. If you have 40 and 400, maybe I'll just show you the scrap work on that. If you have 40/400 like that, well, think about it. 40 goes into this just basically once, so it's actually 81/10. So I'm subtracting 81/10. All right. Now, let's do the step where we turn that into a perfect square, or a square of a binomial. It's a minus, and that is 9/20 squared. 15/1, the common denominator is 10, so that's minus 150 minus 81. So it's over 10, and again, 150 and 81 is 231. So we're looking at 231/10. Now I'm going to add 231/10 to both sides of the equation. I'm going to divide both sides of the equation by 40. I am going to square root both sides, leaving me plus or minus the square root of 231 over, and I know what the square root of 400 is, it's 20. And again, just like the last one, that kind of worked out nice because these two things have a common denominator. So I can say for my final answer, and you can see why I wanted you to take a whole page for this, it's 9 plus or minus the square root of 231 over 20. And once again, let's get approximate decimals for that. So let's see, punching buttons, that's open a bracket 9 plus the square root of 231, close bracket over 20, which is 1.21. And what if we did the minus? Open a bracket 9 minus the square root of 231, close brackets divided by 20, and you get negative 0.31, I guess. And let's see if that's what Desmos says. So switching over to Desmos. Okay, I've seen that one already. There's the one I just did. And let's see, do we get the same x-intercepts? Yeah, negative 0.31, positive 1.21. There we go. And by the way, another thing I like to do when I'm doing these is stop at the step where I had this kind of as one vertex form and see if I have the same equation. And yeah, I do. There's after I've done my complete the square method, I kind of sometimes like to check to see if I have the same equation, and I do. So there we go. Done. Now, here's what I want you to do next. Let's get Desmos out of the way. Go back. We won't use this one for our little activity we're going to do. We're going to use the first one. So go back to the first example. Go back to A, and let's do something that we haven't really done before. We're going to number. Oh, I froze the screen by moving too much. Come on, screen. There we go. We're going to number our steps. So this will be step 1, where we set 0. This will be step 2. This will be step 3. This will be step 4. This will be step 5. This will be step 6. Now, if you added extra steps when you did your work, or if you actually combined some of these steps together because you did it in less steps than me, that's fine. But we'd like kind of a general sense of what all these steps are. 7. And then, of course, step 8 is our answer. So 8 steps to solving a quadratic. And here's what we're going to do with that. We're going to take the example that we just did, and we're going to do every one of those 8 steps to an equation without any numbers. Here is the general standard form of a quadratic, right? Y equals ax squared plus bx plus c. All right, so what did we do in step 1? In step 1, we set y to 0 because we're looking for the x-intercept. So let's do that. 0 equals ax squared plus bx plus c. All right, what did we do in step 2? Well, in step 2, we factored out the coefficient of 2. Well, in this case, the coefficient is a. So I'm going to factor out a. A factored out of here makes that x squared, and it makes this b over a times x. All right, what did we do in step 3? In step 3, we completed the square. This is really the step that is completing the square. And we did that by taking half of this fraction. It used to be 3 halves, now it's b over a. And then we squared it. So half of b over a is b over 2a. And if I square that, I get, let me write this down first, I get b squared over 4a squared. And then we realize that we can't just add a term all willy-nilly to an equation. That changes it, so we have to subtract it right away. But we didn't really add this. We added a times this. And if you, again, use some scrap paper if you need to, the scrap paper would say if I take a times b squared over 4a squared, I can just say that that's b squared over 4a. So I am minusing b squared over 4a, and now I haven't changed the equation at all. Okay, what did we do? That took care of step 3. What did we do in step 4? In step 4, we actually completed our square and combined these two constants. So the first part's easier. We know that that's a plus between them, and we know that that's the square root of this thing, and the square root of b squared is b. The square root of 4a squared is 2a squared. The harder part is adding these two fractions together. This is c over 1. The common denominator is 4a. So I have to times c over 1 by 4a over 4a, making it 4ac minus b squared all over 4a. There we go. That's the same as how I found 65 over 8 in the step beside it. So there, we've just finished step 4, on to step 5. Now in step 5, we have to minus this from both sides of the equation, get rid of the constant. So, because remember, the goal is to isolate for x. So the first thing that has to go is this. So I'm going to minus this from both sides. Now see if you can understand what I did. If I minus this thing, I basically take the opposite of it. So on the other side of the equation, it looks like this. Everybody get what I did there? Okay, so that actually took care of step 5. Step 6 was to get rid of this coefficient. So I'm going to divide both sides of the equation by a, which is going to make this happen. And there we have that. Now I am going to square root both sides of the equation. And just like in the last one, I didn't really know what the square root of 65 was. Right, so I'm at step 7, so I just left it as plus or minus the square root of 65. Well, I have no idea what the square root of this thing is, so I'm actually just going to leave it as plus or minus b squared minus 4ac in a square root. But I can square root 4a squared, just like I was able to square root 16 on the other side. That's actually not a tough thing to square root. I can square root 4a squared and say that it is 2a. And just like what happened in the one with the numbers, I actually have a common denominator now between this constant and this mess. So when I minus it from both sides, I can say that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that is what mathematicians call the quadratic formula. And we can use this formula to solve for the x-intercepts or the roots or the solutions or the zeros for any quadratic equation that we want to, whether it factors or not. So, with that in mind, let's go back to the A example. So that was the A example. And let's think about it as an equation in y equals ax squared plus bx plus c form. So my a value is 2, my b value is negative 3, my c value is negative 7. Remember that the negatives have to kind of belong to the numbers. And let's run it through the quadratic formula, see what we get as an answer. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2 times a. So x is equal to the negative of negative 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 7 all over 2 times a, which was 2. All right, some arithmetic we got to do here. Minusing a negative means that those two things cancel. Plus or minus the square root, and that would be 9. Minus 4 times 2 is negative 8. Negative 8 times negative 7 is plus 56. Those negatives cancel. All over 4. And if you solve that one more step, you get 3 plus or minus the square root of 65 over 4. And if you'll remember a few minutes ago, that was what we got at step 8 for that same question. So we can do that in, let's see, how many steps did that take us? 1, 2, 3 versus 8. It is less work than completing the square. It just means you got to be good at arithmetic. So there's the A question. Let's do the B question now. So the B question was, let's see, what was the B question again? The B question was y equals 2/3 times x squared minus 3/5 x minus a quarter. Okay, looks good. Let me get that cursor out of the way. And step 1 is we set it to 0. And step 2, whoops, that's a 3. And step 2 is we times everything by 60, which we'll do that again. And when we times everything by 60, we got 0 equals 40x squared minus 36x minus 15. So now my A is 40, my B is negative 36, my C is negative 15. So let's use the formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And let's plug in our numbers. So that's 36, because I'm minusing negative 36 again, plus or minus the square root of b squared, which, ooh, I have no idea what 36 squared is. I might need a calculator to help me with this. Minus 4 times 40 times negative 15. And once again, I think I've got numbers a little bigger than I can handle in my head, all over 2 times 40. So there we go. I think I'm going to get a calculator to help me with that. So let's see. If I'm going to use a calculator, you know what? I'm going to use it smart. I'm going to just do this whole thing as one big calculation. So let's see how that goes. I am going to go open a bracket for the entire numerator, 36 plus, open a radical, and open a bracket because I'm going to do a bunch of things in the radical. Some of you have calculators where it opens a bracket for you when you hit square root, in which case you don't have to hit that button the way I just did. 36 squared minus 4 times 40 times negative. And remember, there's a difference between your subtract button and your negative button. So I'm hitting my negative button here. 15. Close the bracket. That's the radicals bracket being closed. Then close the bracket for the numerator, then divide by, you have to open a bracket for the denominator so that the calculator knows to do this multiply before this big divide, and then 2 times 40. Obviously, I wouldn't in the real world do 2 times 40 without just putting 80 down in my head, but I'm just showing you how to punch the buttons. And that then equals, and hey, does that look familiar? That's the number we had when we did it. 1.21, and oh, I pushed so many buttons that I froze the screen. Come back, screen, come back. There we go. 1.2099, so 1.21 approximately. Or the other answer is, watch me do it one more time. Open a bracket, 36 minus the square root of open a bracket. 36 squared minus 4 times 40 times negative 15. Close the bracket for the radical. Close the bracket for the numerator. Divide. Open a bracket for the denominator. 2 times 40. Close the bracket for the denominator and hit equals. And yep, that was the other answer. 0.31. Now, what if you wanted exact answers instead of decimals? Well then, all I would do is I would maybe take a second and write that down as x equals 36 plus or minus the square root of something over 80. And then I'd have to figure out the something. So I'm actually just going to punch just this part. So the 36 squared minus 4 times 40 times negative 15. And that part there is 3696. And so that should be simplifiable. So you'd have to ask yourself, you'd say, self, what perfect square could go into that number? So you're not off the hook with the calculator. You still need to use some number skills to get the exact answer. And I think what we're going to find in here is that there's 144 in that number. If I divide by 144, oops, what do I get? Oh, no, I'm wrong. Let's see. Well, for sure there's a 4 and isn't there a 4 and a 3 in that number? Okay, maybe I'm wrong. First of all, I know that there's a 3 in it. So let's divide it by 3, and what do we get? 1232. And is there a 4 in that number? Yeah, there is. So there's, oh, I guess there isn't. I thought there was a 9 and a 4. There is not. There's a 3 and a 4 in it. So there is not a 9 in that number. Let's see, 3696. I thought there was a 9 in it, but there is not. No. So you can't take out a 9, but you can take out a 4 for sure. In fact, maybe you can even take out a 16. Let's see, can you take a 16 out of this number? You can. So we're going to take a 16 out of that number. I'm a little bit out of space here, so let me just kind of continue on another page. There we go. So let's take a 16 out of that number. So x is equal to 36 plus or minus, and when 16 comes out of the radical, remember simplifying radicals from grade 10? You get 4 root, and what did I get again? Oh yeah, there it is, 231. Does that number sound familiar? All over 80. And then one more step, I can factor a 4 out of the top and the bottom, and I get x is equal to 4 times, let's see, that would be, that'll be 9 plus or minus the square root of 231 all over, and if I factor 4 to the bottom, I get 4 times 20, And there we go. There's our final answer. If you remember back, this was the answer that we got without using our calculator and using the complete the square method. And there you have it. So that's the quadratic equation, and that's how to use it. You've now seen where it comes from. It comes from completing the square. Let's go to our notes. Okay, so turn to page 10 of our notes package, and let's fill this in very quickly. The quadratic formula can be used to solve any quadratic equation. We mainly use it whenever a quadratic can't be factored. When using the quadratic formula, you must set up the equation in standard form, ax squared plus bx plus c is equal to 0, where a is not 0, so that a, b, and c can be correctly identified. And there is the formula. You get it on the formula sheet, so you don't have to actually memorize it. And so that means that the two roots, or the two zeros, of any quadratic equation can be expressed with that formula and that formula, which is basically this, just separated into two formulas with the plus and minus expressed individually. So, just a couple of quick things. First of all, what is the coefficient of x in that equation? Well, in that one it's -1. There's a -1 there. Identify the a, b, and c values here. Well, the a value here is 3, the b value here is 4, the c value here is 8. And let's do a couple. Well, why don't you pause the video and give it a try and see how it goes. Okay, so pause the video here and see how it goes. Try them yourself. Okay, so for the first one, did you get those numbers in the right places? And when you solve that, you're going to get -3 plus or minus the square root, and I'll do this in a couple steps here. So this is 9, -4 times -9 is positive, so this is 9 plus 36, all over 2. And so x is equal to -3 plus or minus 9 plus 36 is 45, so the square root of 45 over 2. Now here's a good question. Should I leave it like this or should I simplify it? In a question like this, I don't care. If you notice that there is a 9 in 45, so you remember from grade 10 that you could factor the 9 out of there and have a 3, you technically have a more simplified answer. So here, let me show you what that answer looks like. It'd be plus or minus 3 root 5 over 2. Now, I don't know that this is necessarily a much better answer than that one. If this denominator had an actual multiple of 3 in it, like the factor of 3 in it, I should say, then of course you would be able to simplify it more, because there's a 3 here, there's a 3 there, and say this had been a 6 to begin with, well, now you could actually make a much simpler answer. But there isn't much difference between here and here. So I tend to stop here if I notice that this simplifying this doesn't make this step any simpler. But if I can see a perfect square in here that I know the square root of it will simplify the denominator, then I definitely will simplify it. So you do have to remember how to simplify radicals from last year. Okay, so there's the answer for A. Give B a try. Maybe pause the video and do that. Okay, here I am after one step. This is what you should look like after 1 or 2 steps yourself. Where did that negative go? Well, remember it's minus b, and b is a negative, so the minus of a negative is a positive. And 6 squared is 36, so that's just easy enough to write down. And then I have 6 plus or minus the square root of, let's see, 36 plus, because the two negatives that are being multiplied here cancel, and I have 8 times 7, which is 56, all over 4. And 36 plus 56 is 92, I think, right? So x is equal to 6 plus or minus the square root of 92 all over 4. And this is one of those situations where, yeah, 92 has a 4 in it. And 4, when I factor it out of here, will be a 2, and it will actually simplify the denominator. So if you stopped here, you'd lose half a mark. You do have to factor out that 4. 4 goes into 92. Leaving you a, what is it, a 23. 23 times 4 is 92. And all over 4. And now I can factor a 2 out of those two things and out of that thing. So that's going to leave me with 3 plus or minus the square root of 23 over 2. And that is the simplified answer for the x-intercepts of this equation, or the solutions, or the zeros, or the roots, whatever term you'd like, out of the 4 you have to choose from. Okay, so that was page 10. Our first example on page 11, which they're calling example 5 now, this one actually does have a fraction to deal with. So rewrite the equation so it does not contain fractions. So that's my first step. So the common denominator here is actually 6. So I am going to multiply the entire equation by 6. Actually, I kind of don't want my leading coefficient to be negative. So I'm actually going to multiply both sides of the equation by -6. So that's going to leave me with 6x squared. When I multiply this by a negative, it becomes a negative. And the 3 goes into the 6, making it a 2, and 2 times 2 is 4, so 4x. And of course, negative times a negative is a positive, and half of 6 is 3. So there. So that's my equation, which is much, much easier to run through the quadratic formula. Let's write the formula down one more time. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, which is minus -4 plus or minus the square root of 4 squared minus 4 times a times c all over 2a. All right, so we have 16, yada, yada, yada. I think you get it from there, right? Okay, so from there, what do we do now? Well, we plug in our numbers and we get 4 times 3 is 12. 12 times 6 is 72. So we get 4 plus or minus the square root of 16 minus 72 over 2 times 6, which is 12. See the problem that's heading our way here? We have now an equation that's going to be 4 plus or minus the square root of -56 over 12. Problem is that we can't square root a negative. This means the equation has no solutions. And that'll happen to you sometimes when you're trying to solve a quadratic. You'll end up with an equation that actually has no solutions, right? And think about what that means for a graph of a quadratic. All right, we'll kind of leave that for you to ponder as we move on to example 6. Example 6, determine the roots of that equation. Determine the roots of 2x to the 4 minus 5x squared plus 2. Okay, so I'm going to use my substitution method on this, and I am going to let x squared equal, say, oh, I don't know, I'll use a. So I'm going to rewrite this as 2a squared, right? Because if x squared is a, then a squared would be x to the 4. So x to the 4 can be simplified down to a, or not simplified, substituted down to a squared, minus 5a plus 2 equals 0. So I can use the quadratic equation on that. A will equal minus the b value, so minus -5 plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which in this case the a value is 2. Right? It doesn't matter that I use the variable a in this equation. In terms of the standard form of a quadratic, this is ax squared plus bx plus c. So this is the a value for this formula, this is the b value, this is the c value. I purposely picked the letter to make it a little confusing. A here is going to equal 5 plus or minus the square root of 25. Okay, let's see if this one has a solution. 4 times 2 is 8, 8 times 2 is 16. Yeah, minus 16, that is going to actually have a solution. So I'm going to have 25 minus 16, which is 25 minus 16 is 9. So I have a is equal to 5 plus or minus the square root of 9 over 4. Hey, that's a perfect square. So a is equal to 5 plus or minus 3 over 4. So a has two answers. If a is a plus, 5 plus 3 over 4 is 2. And 5 minus 3 over 4 is a half. But remember, that is my a value, and I want to solve for x. So x squared is equal to 2, which means that x is equal to plus or minus root 2. And x squared could also be equal to a half. So x could equal plus or minus root 2 over 2. Little throwback to trig. Remember how that works? We simplified the radical that way. And there's my final answers for example 6. All right, example 7. Mark has a rectangular garden that measures 7 by 10. I think we should probably draw that. He wants to double the area of his garden. So he has a garden that is 7 by 10. He wants to double the area of the garden by adding equal lengths to both dimensions. So this has an area of 70, 7 times 10. He would like an area of 140, right? He'd like to double his area, but he's adding the same amount to the length and width. So this same amount we're going to call x. So this is x plus 10, and this is x plus 7. So I know that I have x plus 7 times x plus 10, right? Length times width is equal to 140. I'm going to have to expand that, so that's x squared plus 7 and 10 is 17x plus 70 equals 140. That's a quadratic, so everybody out of the pool. X squared plus 17x minus 70 equals 0. And let's see, can I simplify that? Is there two numbers that times to make negative 70 that add to make 17? You might think, oh, it's 10 and 7. No, it's not, because one of them has to be positive, one of them has to be negative. I actually don't think that does factor, so that's why I'm going to break out my quadratic formula. So x is equal to minus the b plus or minus the square root of b squared minus 4ac all over 2a. So that's negative 17 plus or minus, 17 squared is 289, I think. And 4 70s would be 280, but it's a plus because the two negatives cancel, all over 2. So that's going to be negative 17 plus or minus the square root. What would that be? 569? Am I right about that? 569? 28 and 28 is 56 plus 9. Yep, 569. All over 2. I don't think 569 is a perfect square, so I'm going to have to go to the calculator. So yeah, this is definitely a calculator problem. So open a bracket, negative 17. Did I actually hit the negative sign or the minus sign? I don't remember. Negative 17 plus the square root of 569, close bracket, and divided by 2. And I get 3.42 something. I'll say 3.42. I'll say 3.43. That'll be rounded to the nearest centimeter since this was in meters. So it was a point there. Yeah, 3.43 meters. Now, I'm not even going to bother with the other answer because it'd be negative. And once again, a negative. It didn't say he wanted to take away from 7 by 10. That wouldn't make sense. So that would actually be a ridiculous answer. It would be extraneous. So we're not going to even worry about the negative answer. We know that the answer then is, therefore, he added 3.43 meters to each side. And there's my final answer. All right, that is your lesson on the quadratic formula. Now you can use it to solve any problem where you can't factor and you don't feel like using complete the square. Thanks for watching.